In this problem, draw the shear force and bending moment diagram for the following beam. Okay, here you can see at this end it is beam is fixed supported at this end. Then here the point load is acting at the edge of the other end. Okay. So the first of all, when drawing shear force and bending moment diagram for this kind of beam, the first step is the finding unknown reactions. To find the unknown reactions, first of all we have to draw the free body diagram for the entire beam. Okay. Considering the entire beam, see the free body diagram. W load is acting. Just take this point as A here. R A Y in this direction. R A X because it is a fixed support, and the moment M is acting. Okay, the length here. This is the free body diagram for the beam. So then by resolving the forces we can find the unknowns. By resolving the forces, first of all we have to determine the unknowns. By horizontal resolving forces in horizontal direction, we can directly find R A X is equal to 0, R A Y is equal W, R A Y is equal W. So then by taking the moment around this A point, let's take this is the point A. By taking the moment around A point, by resolving it, M minus W into L is equal to 0, so that M is equal W into L. Okay. Then the next step, we are going to introduce imaginary cut. That means we have to divide the beam into segments so that the loading within each segment is continuous. You can see if you take from A to B, the loading is continuous, so the entire beam we can consider as a one segment. Okay, so then we are going to obtain equations for A to B region. So somewhere in here I am going to section that I am going to introduce imaginary cut from X distance from the A. Okay, so then for this beam part I am going to draw the free body diagram first. Okay, then what are the forces acting on it? The vertical force W is acting at the fixed support end. Then moment from the fixed support, M is acting, and also we have to mark the shear forces. This is the positive way we are marking the shear force in left hand side face after making the imaginary cut. So then the moment acting on this cross section, let's take the bending moment. This is the positive way we are marking shear force and bending moment. Okay, for your knowledge, let me draw the adjacent plane. If there's adjacent plane, how we can mark the bending moment and positive bending moment and shear force? The positive shear force acting upward direction, because the reaction of this face is acting on this adjacent face, and the positive bending moment marking in this direction. That means the reaction of this bending moment acting on this face. Again, similarly, we can mark the, if we introduce another imaginary cut, that means this part is intermediate beam part, something like this. So we can mark the shear force acting downward direction, then the bending moment. Now the shear force is difference. Shear force, let's take dash, bending moment dash. Then you can see due to act of shear force, this separated beam part, beam segment tends to rotate intermediate beam segment tends to rotate in clockwise direction. That is how we are marking positive shear force. And you can see due to act of this bending moment, it is subjected to this kind of sagging bending moment, forming this kind of curvatures. So this is the positive bending moment we are marking and the positive shear force. Okay, then we are going to obtain the equations for shear force and bending moment for considering the A to B region. To obtain that, we are going to consider the forces acting on this beam part. We are going to resolve all the forces in vertical direction. W minus shear force is equal to 0, so that the shear force is equal W. Shear force is equal W. By taking the moment around the point. So then to determine the equation for bending moment, we are going to take the moment around the point. By taking the moment around the point, this length is equal to x from this end. By taking the moment around the point, let's take the moment produced by the fixed support M minus shear force into x plus bending moment is equal to 0. Here M is equal WL minus shear force is equal to WX plus bending moment is equal to 0. So that by making the bending moment into subject, we are getting the equation WX minus WL. This is the equation for the shear force. This is the equation for the bending moment. Then now we can draw the shear force and bending moment diagram for this problem. Okay, let's see how to draw the shear force diagram and the bending moment diagram. Okay, now we are going to draw the shear force and bending moment diagram. We are drawing it just below the loading diagram. Here the shear force is a constant throughout the length of the beam, that is equal to W. Okay, let me draw that one first. Constant. That is equal to W. So then bending moment, here you can see y is equal mx plus c type equation. So negative yeah. So then what happened? The bending moment at x is equal L, the value is equal to 0. When the bending moment x is equal 0, that value is equal minus WL. So we can easily obtain the equation graph by joining these 2 points. This is the bending moment diagram. Okay. This is how we are drawing the shear force and bending moment diagram for this kind of beam.